Good morning, everybody. As is traditional at Spring 1 each year, the first session this morning is Juergen Hoeller introducing Spring Framework 5.3. Juergen, go ahead and take it away.
All right, welcome from my side. Thanks for the introduction. So I've got the pleasure of introducing, as I'm calling it here, Spring Framework 5.3. This is still hot from the oven, right out of the development team. We are going towards a release candidate phase starting in mid-September, so this comes very timely at this point. And I'd like to give you the opportunity to just review some of the major themes of the 5.9, how 5.3 really fits into it, how 5.3 concludes this particular line. So you'll learn and hear a bit about our release planning efforts as well. And of course, there's going to be a personal selection of feature highlights and particularly noteworthy efforts that we are bringing into this release. So there's plenty of material to cover, and let's get right into it. Just a moment. Yep. So much for that. So let's just take a brief look at not only the current efforts, but the efforts, the larger scale roadmap that this fits into, the larger scheme, the larger plan. We are really talking about the Spring Framework 5 generation of the framework. Spring Framework 5 was set out like a couple of years ago, set out to focus on 4 particular themes. And these themes were never meant to be fully covered in the 5.0 release. They were always meant to be the driving themes for the entire Spring Framework 5.x generation. So those themes might be well known in the meantime already. This is, of course, the Java 8 baseline, but it's not just the Java 8 baseline, it's also the forward-looking part of it. Support for Java as we know it now, the half-year iterations that started with Java 9. So in the meantime, we're already approaching 15, so there were quite a few releases to cover. So this is a particular focus, but not only Java the language, but also as a sort of preferred alternative language on the JVM. There's a lot of dedicated Kotlin integration. So starting with Spring Framework 5 and fine-tuning it and completing it over all the feature releases. We introduced a lot of Kotlin extensions in the core APIs, the core container, but in particular also in the endpoint models, like the web endpoint models, the messaging endpoint models. There's plenty of Kotlin goodness to be found. Not a specific focus of this presentation today, but always keep it in the back of your minds. Whenever you're seeing a Java example, there could be just as well a corresponding Kotlin example fitting equally well into a particular part of the Spring Framework 5 component model. There's a dedicated effort towards functional configuration and functional endpoint registration. So the functional is really functional as in Java 8 functional. You'll know it when you see it, right? It really fits into the Java util collection stream model. This driven style, more like build APIs, built with lambdas. That's really what we mean by functional. And the goal, and to quite some degree, 5.3 is the reaches an initial conclusion for what we mean to accomplish here, was really to bring functional registration to the most important parts of the framework overall, as an alternative to an annotation-based configuration, to a degree where you could even select between a functional and an annotation-based registration model, but also all the shades of gray in between, combining functional registration with certain annotation-driven features in the component model is very much the sweet spot in Spring, and a particular sweet spot in Spring overall that it even allows for all those custom combinations of features. Last but not least, there has been a dedicated focus on reactive programming. We'll see a bit more in a moment, but the reactive programming part of it also it started in 5.0, and it's a co-evolution with Project Reactor. So this reactive API and this reactive runtime kernel that we're using here really co-evolved with us over those feature releases over those couple of years. And of course, a lot of features have been added towards feature parity between like reactive and traditional programming equivalents in Spring, but also towards a more specific reactive focus, where we're trying to complete and extend the specific reactive nature of the framework, of the reactive SPIs, the reactive options that we're giving to you. Since fundamentally we are not just mirroring some existing APIs, we really started establishing a dedicated reactive programming model for the Spring ecosystem. All right, so much for the themes. Just to give you an idea of how we translated this into releases. Remember that it started with 5.0, like about 3 years ago, and of course. It wouldn't be where it is now in terms of adoption if it wasn't for Spring Boot 2. So the Spring Boot 2 generation also started building on Spring Framework 5 right from the start, basically. The themes may have been set by the core framework, but they have been picked up by many portfolio projects and by Spring Boot itself. And Spring Boot bringing together all those portfolio projects in itself was and is a very important piece of the puzzle here. All right, there were many things that we have been starting back then. The Java 8 baselining, all the nullability efforts. You might have seen all the nullable annotations and the non-null by default convention that we're using for the Spring APIs. Strict and complete definitions for parameters that may be null, for return values that may be null, or in particular, for return values that may not be null, where certain assumptions can be made by callers. This is part of the sort of aligned with the Java 8 baseline upgrade, but it's also motivated by Kotlin to some degree, allowing Kotlin language features, non-null variable declarations to cleanly pick up results from Spring API calls. We started some initial functional registration models for beans. Of course, all the Reactive support saw the light of day for the first time in the 5.0 release. And even WebFlux was already a very developed effort that came out of a research project initially, and already came in 2 flavors those years ago. Now as an annotation-based Spring MVC equivalent, and as a separate, like, functionally styled router function, handler function arrangement, allowing you to tap into the same infrastructure underneath. And well, this is of course not a complete list anyway, but JUnit 5 is also something that started in terms of our test context framework and support for JUnit 5 back then. And JUnit 5 also co-evolves with us here. Not least of it all because one of our core framework committers, Sam Brennan, is also a key contributor and a key committer on JUnit 5 and JUnit Jupyter. Right. So to keep the run through brief, we did a feature release every year, and the corresponding Spring Boot releases initially every year. As further Java releases came out, in particular the Java 8, the Java 11 release, which was the first long-term supported release by the major JDK vendors, including Oracle themselves. But more importantly, we started completing the feature sets. We had initially had bean registration facilities in a functional style, but it was really missing a bean retrieval facility. in a similar style. And 5.1 saw the introduction of the current shape of object provider and the get bean provider methods on the factory that allow you to interact with the container, retrieving beans of a certain kind in a stream-like style. Another thing that we are constantly picking up, of course, in terms of new releases is Hibernate as the most popular choice of object relational mapping provider with Spring, and 5.3, Hibernate ORM 5.3 was a particularly important one with bean container integration, close integration with bean container facilities in Spring. So this was really another level of Hibernate ORM integration that we're able to provide since 5.1. The 5.2 release saw a lot of refactoring internally. So you might not have noticed, but there's a totally new implementation for annotation retrieval and for internal annotation caching. By type lookups in the core container have been significantly revised in 5.2. But in terms of feature set, in the feature set itself, 5.2 introduced reactive transaction management. Initially without an implementation that we're shipping, and we'll get to that a little bit later. But it introduced a support for add transactional and any other transaction demarcation mechanisms in Spring to also handle reactive return values, basically reactive streams publishers and equivalents, to know what to do with them, to decorate them with a transaction demarcation that certain resource integrations can then pick up. We started supporting RSocket from very early on, and this has also been a major theme in the past 12 months. So 5.2x and also 5.3 itself are bringing a lot of RSocket refinements, RSocket support refinements. RSocket is a reactive messaging arrangement, reactive messaging abstraction, very flexible, different usage models predefined. It also made us introduce a reactive equivalent of the Spring messaging endpoint models that RSocket is built upon, the RSocket support is built upon. So there were quite a few general features and general revisions in the messaging module driven by the RSocket support. We have initial support for Kotlin coroutines, which is an adaptation for our reactive stream support ultimately, but with a nice Kotlin language feature on top that underneath the covers adapts to our reactive stream support. So many of the reactive features can also be used with Kotlin coroutines as a language feature when using Kotlin to begin with, of course. A quite significant step we were taking was a functional equivalent for WebMVC and WebMVC endpoint registration. We had it for Webflux. We had annotation-based support in MVC and Webflux. We had functional support in Webflux. And 5.2 was finally bringing a functional model for WebMVC onto the table. Basically modeled after Webflux FN, very similar in style, but working with the servlet foundation and the servlet programming model and the servlet runtime model. So servlet invocation semantics underneath the covers. So it's not built on reactive abstractions, it's built on traditional one thread per request handling servlet assumptions. All right, and we'll get right into 5.3. Now, this is a release that will come up towards the end of October. From where we are now, release candidate 1 is supposed to happen in mid-September, so very soon now. And this is going to be the foundation not only for the Spring Boot 2.4 release, but also for the 2.5 release. It was already Spring Framework 5.2 being the foundation for 2 boot releases, since boot releases happen every half year at the moment. And the same is to be expected for Framework 5.3. But potentially even one more. It might even be a 2.6 built on 5.3, and we'll get to that. So, of course, this is a continuation of the story. So there's many refinements that we're not even talking about today. But in terms of significant steps taken, This is now the foundation for the Spring GraalVM-native project, so for our early adopter project for native application deployment. There have been many refinements in the core framework. There have been some before for even earlier adopters, but there have been very significant and to some degree complete and comprehensive steps taken in 5.3. 5.3 also brings not only Java 14, but also Java 15 support, which is going to be released in a few days now. It's still in preview in those releases, but record classes, records, are a really nice language feature in Java itself. Very convenient, bringing a sort of Kotlin-like, Kotlin data class-like feeling in some ways. And our binding support for data binding in various places has been embracing records conventions. I'll highlight a few specifics later on. An area of focus is certainly the database support. The classic Spring JDBC support has been upgraded in quite a few ways, but we've also been introducing a dedicated Spring R2DBC module. R2DBC is a reactive relational database access abstraction, basically a sort of JDBC equivalent for reactive database drivers. And the R2DBC effort is in the meantime GA, so it's production ready. Several drivers available, for example, the Postgres one, very actively maintained. The R2DBC module is similar to the JDBC module in style, but it comes, of course, with a few reactive specifics, and it also comes with the benefit of having 15 years and more experience behind it in terms of how we're modeling database access. Spring JDBC has been one of the earliest modules in the Spring Framework umbrella, dating back to the old .NET days, 2003. Whereas, of course, R2DBC is a much newer effort. So in some ways, it's a streamlined version of a data access module. And it's also had the benefit of the Spring Data project, already having launched the Spring Data R2DBC module earlier on, about a year ago. So in some ways, this has been factored out of Spring Data R2DBC with quite a few lessons learned there already, and some real life feature completion feedback already having gone into it. A couple of Spring MVC refinements, we'll get to that, and having a baseline upgrade is also something we had to do at this point in terms of completion efforts. Now let's get into some specifics for 5.3. This is going to be what we call a release with an extended maintenance phase. So it's basically long-term support with Java calls long-term support for the JDK. Just like the 3.2 generation, for the 3.x line, those branches have seen multi-year maintenance as kind of the last feature releases in a major generation. So 5.3 is going to be the final feature release in the 5.x line, and as such, it's going to see an extended maintenance phase. This brings a couple of challenges in this world that we're in now, in the Java ecosystem that we're in now in 2020. Because of course, we can't just say like, this is it in terms of JDK generations. We really have to be a little more forward-looking. 5.3 launches against a JDK 8 baseline in the framework, and a sort of JDK 8 baseline also in the enterprise out there with many JDK 8 installations still. And of course, we're picking up JDK 15 already, which is going to be released in September, as mentioned. So it's a wide range, 8 to 15 at launch time. But we're already, to the degree that it is technically possible, we're also going to embrace JDK 16 and 17 as they are coming up next year in 2021. We're expecting JDK 17 to be declared a long-term support release again. And in that role, as the next long-term support release after 11, it's hopefully going to see some real adoption in the enterprise. And Spring Framework 5.3.x-based applications and corresponding Spring Boot applications should be able to just have a very smooth upgrade towards JDK 17. To the degree that we can foresee it right now, this should be pretty smooth. We're already pretty aware what JDK 16 brings, and we don't expect many surprises for JDK 17 itself. This does not only include deploying existing applications to a newer JDK or Java runtime. This includes, of course, also the development of new systems, of new services, the upgrade of existing code bases towards the language features and API features that those new releases bring. And to the degree that it is also technically possible, we're also supporting preview features. So you can already use it right now. They might only go live as a non-preview feature in JDK 16, but you can already pick them up now in JDK 14 and 15 within the Spring programming model. For any further preview features, we expect to be able to do the same, so that you can pick them up at your own pace as preview features or as production features, as official production features, as you see fit. So we're not making that choice for you, you're making the choice, and we are supporting in that effort. There's quite a bit of effort that went into the core container itself. You could almost say as always, right? But there's been some particular work for native application, for deployment, for building native images with GraalVM. In particular, we are allowing for deactivating certain code paths that are typically not needed in native image applications, in native applications. There's a couple of flags that allow you to switch off across the framework, basically, certain features that are known to cause some increase in the image size or in the memory representation at runtime. For example, XML support and Spring expression language support are sort of a little heavy for simple applications if you're not using them. So you might not notice in a regular hotspot application where things are just not being loaded, not being picked up and optimized at runtime, but native images work differently. You have to make assumptions at native image generation time, and being able to exclude larger areas, feature sets across the framework is of great value there. Instead of having to manually kind of fine-tune all sorts of places, a simple flag might do the job and significantly improve native image generation times, native image size, and runtime memory usage to some degree as well in the native image. The other area, of course, that caused some deeper changes is the Java record class model. We're going to see an example in a moment. The idea behind records is that they're sort of an independently motivated and independently designed language feature. So they intentionally do not align with Java Beans conventions in terms of how you would work with them from a usage, from a programming model perspective, but also in terms of how they represent themselves at runtime, so how the framework is seen. Both of those views have kind of a little different from Java Beans. We are supporting both conventions now for most data binding purposes in the framework. We already had constructor-based binding support before for, say, Lombok data classes, Kotlin data classes, similarly styled Java classes. We are approaching the record topic here with the same mindset. So we are supporting not only Java 14 and 15 records as they come as in the preview feature here. We're also supporting similarly styled classes that are created with any other means, right? Handcrafted even. So we're really seeing it as a convention-based binding arrangement. To give you an idea of what this means, a simple Java record for a person might be very easy to declare with the actual preview feature in Java 14 and 15. But ultimately, it's not that different from a manually generated, manually coded class with the corresponding fields, a single corresponding public constructor, accessor methods that are not named with a get prefix, but rather basically named along the field name, named along the constructor parameter name. So not get first name, but rather just first name. Then, of course, for completeness, you would have to add an equals implementation, a hash code implementation, and a toString implementation. And you basically have what the record class gives you. Of course, it's much nicer if you can actually use the record feature. But the important part here is it's really about conventions for the structure of a class, for its constructor, for its accessor methods. So in that sense, it's a set of conventions, the way we're seeing it, just like Java Beans were. The record language feature in Java 14 and 15 matches those conventions, obviously. That's what it's been modeled after. But any other classes that manually follow those conventions are also going to be supported, automatically picked up, or wherever Spring Data Binding kicks in. This is in particular the case for like web handler methods, where you would bind request parameters onto a target object. You were able to do this with a Java bean with setter methods and getter methods. You can also use a constructor-based bean with constructor-based conventions, and if you choose to do so, also with record conventions. So we also have constructor-based conventions with a immutable design, a single public constructor, and getter methods. Of course, that's kind of a little in between. Truly record convention style is constructor and these plain accessor methods. So whatever design you're using, we're going to pick it up for you. You don't need to explicitly opt into this. We're going to see what you're giving us, what you're declaring, what the structure of your given class is. In the JDBC space, we're actually picking up on that particular end as well. We are introducing a data class row mapper, which is sort of a variant of the bean property row mapper, where we're also applying those constructor-based conventions for you. So we are basically taking a given row in the results and we are binding it to a specified target class that you're specifying. And we are finding out how to do this by looking at the class, right? If it follows data class conventions, we're using its constructor. If it's a traditional Java bean, we are going to use its setters. So it's a pretty flexible arrangement. It includes not only the constructor-based capabilities, but also bean property capabilities. So to give you a sweet spot, or well, an interesting spot here, you can also design classes that are partially populated through the constructor, following data class conventions or record conventions. And you can also accept some remaining properties that might, for example, only be present in certain result sets. You can also accept them through setter methods. So you can also combine a constructor, partial constructor, with a couple of setter methods as you see fit. So those classes don't have to be immutable. Again, Spring lets you also explore the shades of gray in between. Immutable constructor-based classes, traditional Java beans, a combination thereof. And data class row mapper, of course, also works with the other kinds of data classes, Lombok, Kotlin style data classes. So it's convention-based, just as traditional web data binding is. There's a little interesting a note hiding here. It's the JDBC transaction manager. If you're double checking what we used to, or what we traditionally ship there, that transaction manager has been called data source transaction manager. Still exists, of course. The JDBC transaction manager is a minor extension of the data source one, and it brings a sort of ORM style feature with it, a very little one. It's data access exception translation on commit and also on rollback, but it's mostly meant for commits, where we recognize that certain databases, Postgres, for example, they might throw interesting exceptions like constraint validation exceptions, that sort of stuff, very late, not on execution of the statement, where we usually apply data access exception translation, but as late as the JDBC commit call. Only then certain constraints might be evaluated, and only then they might throw. So previously, you always got the transaction like system exception out of this, not the corresponding data access exception. In ORM land, in object relational mapping, with JPA and Hibernate, this works a little differently because we're usually flushing everything up front right before the commit. So the commit is kind of flush in the resource commit. For that reason, because the flush spits out a lot of statements and might generate a lot of data access exceptions, many kinds of thereof. We always applying data access exception translation there. So this sort of works in ORM land, where we are trying to catch those flush exceptions. We never had that for the plain commit in JDBC, but as elaborated with certain databases, at least there's value in doing this. So long story short, this is JDBC Transaction Manager. It comes with this additional data access exception translation feature, which is somewhat complex, but built in, automatically happening just by choosing JDBC Transaction Manager instead of Data Source Transaction Manager. If you don't care for the additional exception translation, it's still a good choice because it doesn't hurt, right? So you can always go with JDBC Transaction Manager from factor 3 onwards if you feel that's a good choice and a good name, right? Because it's aligned with the JMS Transaction Manager, the JPA Transaction Manager. All right. Another interesting feature here is an interesting addition is query for stream on the JDBC template. JDBC template, of course, being a very old class, has many traditionally styled access methods. What we're adding here now is a Java util collection style, Java 8 style method query for stream, literally returning a closable Java util stream as you would get it from the collection stream method, allowing for lazy iteration over a result set with the same API that you are using for lazy iteration over a collection. Right? So it's a stylistic alignment with collection streams is a key part of what we're doing here. Well, this is primarily a stream example, but it's also it comes in two flavors, right? It's also an example for the data class row mapper. This is basically how you would use it. You get a result stream and then you map your way along, right? Or you select your way along with, on the stream. So you can always reduce it to a single result. You can try to turn it into a collection, of course, but always with lazy iteration guarantees. And here you can also see a nice example for the data class row mapper, because if what you're doing is direct mapping of fields in a row onto a constructor in a target class, then data class row mapper does exactly that. It can do it with records, it can do it with custom classes that are using the same design, or these more traditionally styled Java beans as well. And in the example below, there's a handcrafted Java 8 Lambda expression that basically does the same thing. It's specifying a row mapper that takes two fields out of the row, manually passes them into a constructor and returns an instance of person for every row within the string. All right, I was mentioning it before. There's also R2DBC support. This is, of course, totally new at core framework level. It's a new module. It's bringing R2DBC, but it's, as mentioned before, it's not totally new in the portfolio. It is basically a sort of factored out core support from the Spring Data R2DBC module, which primarily focuses on Spring Data's repository abstraction, repository interface model, adapting that to R2DBC, but there's a lot of core support underneath. And it's that core support underneath at the same conceptual level as JDBC template and our data source support. And that's what we're bringing into Spring R2DBC. It's connection factory setup. It's an R2DBC transaction manager. So it's all the transaction management for the first time a reactive transaction manager implementation that lives in the core framework. So personally, I love it just for that already. It's sort of the reference implementation for the reactive transaction manager SPI. And of course, all the support infrastructure around that. And then there's also a database client. Database client is sort of JDBC templates revisited for R2DBC for reactive database access. But it's also modeled along the lines of web clients in Webflux. So you can see there's REST template for traditional client-side web access. And there's now the web client in Webflux. Now in terms of relational database access, we got JDBC template, and as a reactive equivalent, we got the database client in the Spring R2DBC module now. So you might almost guess what the design looks like. This is basically how you go about it, web client style. You're building a database client. You can, of course, keep it around. And then you're using that client as a sort of builder style interaction API, a fluent interaction API that does something very similar as what you've been seeing before. Query for Stream in particular. So this is sort of very, very analogous what you're seeing here now. But it uses R2DBC underneath the covers. So the original R2DBC API as defined on in R2DBC proper, and as you can see it on r2dbc.io on the website, is showing through here. So no JDBC result sets, no JDBC connections, no data sources. It's all R2DBC naming, and it's R2DBC representations of the underlying data. Moving on to Spring Web MVC, we have a couple of alignments. I'll just quickly mention we have a mapping implementation for Spring MVC, basically the part that maps a request onto a particular handler method that now uses the path pattern infrastructure, the same that we're also using by default in Webflux as an alternative to the more traditionally styled path matcher. This is largely a runtime optimization, so path patterns are very capable and powerful in terms of avoiding overhead, right? So they are a very efficient way of performing such a mapping for commonly requested handler methods. And there's also a little addition on the testing side. We have a web test client now that you can bind to, that allows you to be bound to mock MVC. So web test client can now be used with a sort of mock server, a mock MVC setup, or a live server, and you have the same single test client API for it. In Webflux, we're singing a similar song, right? In terms of we're mostly doing re-implementations of certain infrastructure for runtime optimization purposes. We have a new implementation for multi-part request parsing and handling, which is our own custom implementation, fully reactive implementation, as an alternative to the synchronous library that we've been using before, which imposed certain limitations on us. And we have a new web client backend based on Apache HTTP Components 5 as an alternative to the backends that we already had, the JD1 and the Reactive based one. All right. I was already hinting at performance tuning, so let me give you a few further ideas of what we do here. It's really very fine-tuned work, right? We had a dedicated revision across the code base for hash map presizing, where previously there, in certain cases, even runtime generated hash maps returned from co-container methods, they would automatically have to kind of double their size to accommodate the number of entries. And now we specifically pre-calculate the size to a degree where it's not oversized and not undersized, and not runtime resizing initially. So fine-tuning things at that level may seem a little overly specific, but we have a couple of contributors who are very actively also running benchmarks against this, and things do make a difference. The more hotspot the particular code path gets, right, the more often it is being called at runtime, the more it shows, of course. We also got rid of, as a sort of side note, we got rid of most of our use of linked lists and replaced it with a release, in particular also with array deck. So for collection optimizations have, for better or for worse, been a topic here in 5.3. I hope we've had the final pass for it already. I'm not sure there's much more to optimize from where we are now. Almost more importantly, because it can make a more dramatic difference, we have a dedicated focus on optimizing concurrency, concurrent access to data structures within the framework. This is not only about the coroutine itself and its locking of the singleton beans, but that itself is a key area, of course. It's about all the internal caches that the framework has all over the place. And for some of the caches, at certain points, they would be fully synchronized in terms of their access because they were bounded and kind of trying to evict old entries and that sort of effort. For all known hotspots that we had there in terms of internal caches, there's now optimized representations, optimized implementations, custom implementations, even for the data structures, avoiding locking to the best degree possible, right? So that we're not overusing traditional synchronization, while of course retaining all the visibility guarantees that we want to expose for concurrent access. Some of this has been backported, so you're going to see some of it, you're going to get some of it in the 5.2.9 release as well. Some of it even got backported before, but you're only really going to get the full story in terms of the optimized data structure revision in the 5.3 release. All right, of course 5.3 naturally is in very active development right now still, right? It's not even in the release candidate phase yet, so we have some work to do still. But even beyond the point of going live in October, of becoming generally available, we expect very active development on the 5.3x line for well, a significant period, right? At least a further year or two, where of course, this is motivated by the extended maintenance phase, but the maintenance phase is much longer, like until 2024, at least. The more important factor is that Spring Framework 5.3.x is going to be the foundation for Spring Boot 2.4 initially, coming in like November this year, for Spring Boot 2.5 coming in like May next year, and potentially even for a 2.6 like in October, November 2021 next year. So it's the foundation for several boot releases building upon it. So for that reason alone, it has to remain in active development, but we really mean it. It's kind of the end of a certain generation, the last wrapping up of that generation. And there will be things that we have missed. We were trying to be comprehensive with the 5.3 development efforts, but there might be stuff that we missed. There might be stuff that we can only do once third parties have released. We can only do JDK 17 support once it's out. We can only pick up new Hibernate releases, whatever they are, as they actually come out. Spring Framework 5.3 is motivated by basically, it's meant to become a natural upgrade path for long-lived Spring applications. All existing Spring applications, not only 5.0, 5.1, 5.2 based applications, but also older applications currently being on 4.3, for example, should find a natural upgrade path here to the best degree possible. And certain things we're only going to find out when people attempt to upgrade large existing code bases, large existing systems. I'm sure we're going to get the corresponding feedback and we're going to fine tune 5.3x. We really want this to be the natural and sort of ultimate upgrade path at this point for all existing Spring applications. For that reason, while we have deprecated some features in 5.3, we haven't really removed anything significant. I mean, minor bits in certain places, we always retain the right to do things about it. But in the grand scheme of things, there haven't been removals. So whatever style you're using, whatever APIs, whatever flavor of the programming model that you're using, you should find yourself comfortable upgrading to 5.3. And the same applies, of course, also to starting new applications, whatever style you're using. All the classic Spring features, as classic as in Spring 3 and 4, but also classic as in Spring 5. You're going to find everything you need, basically in one single generation of the framework in 5.3x here. There's a couple of sort of forward compatibility intentions that we have. JDK 17 in particular, whatever it takes. For late next year, but to some degree also around that, beyond that, we expect Project Loom bringing virtual threads to the Java platform. We expect it to go live soon in an initial cut. We don't know what soon is, right? It might not make JDK 17, but it might become available as a preview, at least in some form, in some more usable form than it is right now. So sort of an official deliverable or as a preview feature maybe in JDK 17, we'll see. And to the degree that it is technically possible, we intend to empower Spring 5.3 based applications to use virtual threads or a virtual thread setup, Tomcat with virtual threads, whatever setup you're using. We intend to do anything it takes to be a proper citizen, a good citizen in such a virtual thread setup. As far as we understand right now, to the current shape of the Project Loom development effort, this should really be a very seamless and straightforward alignment. And everything that we could anticipate, we already anticipated and did, but then there might be further stuff coming along. All right. There's of course also stuff we won't be doing in 5.3. Well, there's only a couple of weeks left, right? So in terms of major steps that we're taking, you're going to see all of those steps taken before GA, of course, before we go live. Some certain steps we might like that are significant, we might still take in the 5.3x line if there's enough demand and if it's technically feasible. But there's stuff we won't be doing. We're not going to large scale remove all the features, as outdated as they may be, right? So beyond 5.3x, there will be a feature release. We're basically talking towards a sort of Spring Framework 6, where there might not be traditional EE support anymore, no EGP support, no JCA support, possibly not even JXWS support, where we might also get rid of certain Spring-specific features that kind of uplift themselves, right? Where RMI invoker, HTTP invoker, they come with so many drawbacks that we might stop shipping them in a new major generation of the framework. Even the XML configuration format is a candidate for, do we have to keep it around? Of course, at this point we do. It's not deprecated. None of this is deprecated right now. So it's fully supported on 5.3x. But in a major revision of the framework, we might raise those questions. Questions not only for ourselves, for the team, but also for the community. So we are going to reach out and find out what is still needed for modern day Spring applications, for newly started applications in particular, and what is not so important anymore these days. Another very important step that we might be taking as the industry, as the Java ecosystem embraces it, is the upgrade to the Jakarta namespace versions of the traditional EE APIs. Most importantly, Jakarta.servlet and Jakarta.persistence, the servlet API and basically the JPA API. What we're waiting for here is not so much the availability of those APIs, because those are just repackaged versions of the Java EE8 APIs with no new features basically in Jakarta EE9. So there's no immediate value here initially. More importantly, it's about the further evolution. If they're going to be Jakarta EE10, 11, bringing new API features that are useful to us as framework integrators, or even that might be exposed directly for application usage. We'll see, right? not happening right now, where we have to make assumptions about the next couple of years. But even more importantly, it's about providers making that choice. Say Tomcat, up until Tomcat 9, will be based on Java Servlet. Tomcat 10 and onwards will be based on Jakarta.Servlet. Tomcat is a very important, the most important piece of infrastructure that we're integrating with, I suppose. So it is, of course, a topic, right? If Tomcat 10 and higher choose to be based on Jakarta.Servlet, then we'll also follow along. And since JD11 very recently also made the decision to have at least very early access implementations in parallel to JD10, which is traditionally based on Jakarta.Servlet, on JavaX.Servlet, Java E8. They also have a Jakarta.Servlet based version of JD11. So as these important steps are being taken out there in the ecosystem, we are going to follow along. So from where we are now, it looks like the next major generation of the framework is going to switch to the Jakarta namespace versions wholesale, as long as not only the web containers, but also the common persistence providers in particular are switching as well, right? We need a Hibernate version, a Hibernate ORM version built on Jakarta.persistence for being able to support Hibernate in such an arrangement. These things have yet to happen, and at this point we are not even seeing hard promises. So we are waiting on some certain projects and on the decisions that they are making, and we expect to follow along in a reasonable time frame. And there's also some streamlining for native application support that we will only be able to do once we are able to prune certain features, remove certain outdated features. So to get further streamlining for native image generation, applying harder measures to the code base, in particular to outdated parts of the code base, is important. So not only for GraalVM native image support, but also for whatever will come out of Project Layden, which is the native application effort in the OpenJDK project itself. Whatever will come out of it will align with it in one form or the other, but it will only really happen in the next major generation, in what in all likelihood will be named Spring Framework 6, without a concrete target time frame yet, right? So these are just basically things we are collecting to be done once the time has come, right? Once those third parties have moved on, once Project Layden actually delivers concrete roles and features. So we're going to pick this up when the ecosystem out there is ready for it. No hard target time frame from our side at this point, at least. All right. This is all I had for you today. So quite a bit of insight into our roadmap planning and our roadmap thinking, which I hope is useful to keep in mind, and also some concrete features, of course, in 5.3 and some concrete, rules and policies for how we're going about Spring Framework 5.3.x for the next few years. So I hope you enjoyed the presentation. I hope you're enjoying the upgrade. So please let us know how it's going as we approach RC1. It's perfect time to give things a try. So please just pick it up and let us know. Do a smoke test upgrade of the application and let us know how it goes. There are further sessions at Spring 1 here, diving deeper into certain topics that I've only been loosely touching upon. There's a dedicated session for the path towards native applications with Spring Boot. And there's also a dedicated R2DBC session here, which I highly recommend if you're interested in those particular topics. Basically, a lot of what is being said there is immediately connected to the 5.3 story. All right, so thanks for your attention and keep the feedback coming, either right now in the Q&A or, of course, on all the other channels on GitHub.
Okay, thanks, Juergen, for that deep dive into Spring 5.3. For those watching, we have a Q&A session starting now in case you need to ask Juergen anything about what you saw. To join, go ahead and click on the Zoom link on the breakout sessions page, and you'll be taken directly to that Q&A area. If you don't have any questions, grab a quick coffee, and we'll see you for the next session in a few minutes. Thanks.